Does that make sense to everyone? Can we turn off one of the lights so we can see this better? Can you see this at all? Alright, okay. Just do this so we can. There you go. Alright. So, as I was saying, basically your drawing is a way to communicate with manufacturers as well as for you guys to be able to have a drawing when you're cutting stuff or taking measurements to be able to compare it to instead of just having it in your head or guessing. And when it comes to doing it on a computer, it's a lot easier in terms of being able to change it quickly, or just you don't feel as invested into it as if you were to hand draw it. And that takes a lot of work. Because you have to make it look nice if you hand draw it and everything like that. And so basically I'm going to give a little bit about CAD. I know I've talked with some of you, maybe it was more in the afternoon session, about what CAD can do. And anybody know what I mean when I say CAD? Alex?
Computer design.
Exactly, yeah. And so with, there's a lot of easy stuff. So SketchUp is a free one that you can use. You can also use Autodesk Fusion, which is free. If any of you have EDU emails, you can use Autodesk Inventor. Right now, I'm using SolidWorks because that's what I'm most familiar with. But they're going to have the same functionality in terms of SketchUp. It's maybe not as much, but Inventor is going to do it just a little bit way of doing it. And just for this, I'm using SolidWorks because it's easier for me to explain if I know what tool that I'm using better. And so then the idea with these CAD is you have an idea of what you want to create and you have an object. For example, if I just have a box like this, this is a little bit more complicated, I'll get into that, if I look at the 2D shape of it, it's a square. And the idea with CAD is you extrude shapes or you can cut shapes. For example, if I wanted to make a box, I would first do my 2D sketch. Typically you dimension these two. I'm not going to do that just to show you. And then you can extrude it. So let's extrude 5 inches. Now I have a box. Fairly simple, but to do more complex shapes, you can do that, and then you can actually do something called cut. So if I wanted to cut a circle into here, I draw my circle, I dimension it properly, which I'll get into a little bit later, and then I would cut it. So in Inventor, extrude and cut are going to be your same button, but it's a different selection that you have to do. In SketchUp, I believe it's the same button as well, I'm not positive, but now I have a hole through my square or my box. And basically you're going to be, that's very simple CAD. There's a lot of other stuff you can do, so you can do spirals and different textures, so you can take one shape so you can make a circle into a square over a specific path as well. But that's more complex. You guys hopefully don't have to worry about that for your projects. If you do, I can show you how to do that. So you can do that. The other big thing for just starting off is, so over here you can see that this is called your feature tree. Basically this is going to be all the things you do. And so with CAD, this is like parametric modeling, which basically means I can go back to what I had before and change it. So if for some reason my sketch that's too big, I can go back, change my dimensions, exit my sketch, and the whole thing's going to be changed. And that makes it a lot easier for the quick design changes as well. And so if I wanted to do, the other big thing other than extrusion is called revolving. That's basically just having your sketch and revolving around some axis. And so that's how you would create rings or rods, something like that. Feel free to interrupt if you have any questions. I know this stuff is pretty boring, but it's pretty important if you want to go into product designs or anything like that, and actually start designing stuff. So that's basically how you would do a basics of CAD. Let's make this a little bit better. But the important part, so in terms of manufacturing stuff, there's a lot of different ways to manufacture stuff. There's a 3D printer. Typically that's going to be used for prototypes. You want something quick, you just have it modeled up, you can print it, share it, email it back and forth, and that's going to be your 3D model. But when you actually go into production, you can either machine it, so that's doing like mill, so you're cutting it similar to like Dremel back there, band saws, lathes, all this is ways of cutting the material. You have one operator who's doing it, and typically that's going to be in low production batches. When you want more, you're going to start going into, or you have higher tolerances. Does anyone know what I mean by tolerances? Anyone other than Josh? Go for it.
Tolerances are the level in which, like how precise the measurements have to be.
Exactly. And that's something you're going to define on your drawings. And so that's really important when you start getting into stuff that has a lot of parts, like cars. It's very important. Part of it is your fit. You want to make sure everything fits together, so you have to make sure it tolerances properly. Also, what is it doing? If for like a hinge on that camera mount, you want it to be toleranced properly so it can fit together and it can act as a hinge or be able to turn as it's supposed to. So it has a lot to do with the fit and function, and that's what takes a lot of time with drawings, making sure you have your tolerancing right. For your projects, just because they're not as complex as some, your tolerance, and because of the tools we have and we're able to provide, your tolerancing doesn't have to be that tight. But for some stuff it does. And so if for that you're going to do a CNC machine. Anyone know what CNC is? Anyone other than Josh? Mark?
You can sort of think of it as a 3D printer, except it has a drill, and you can connect to your software. And if you want to cut something and make precise cuts, you can either put on like a board of wood, and the software will control the drill and drill in the precise places that you want.
Yeah, so that's basically right, except CNC stands for Computer Numerical Control, and it's basically that is a CNC machine as well. It doesn't have to be a drill on top of it.
Okay, it doesn't have to be, okay,
yeah.
Sure.
And so there's other things, so you can do wire cutting with it as well. Wire cutting, so basically it's a way to automate your process so you don't have the operator at the mill or at the tool doing it over and over again. And that it can be expensive just for the more complex part because you have to set up the tooling for it. But in the long run, you're going to have better tolerances on your parts, which means you're going to have basically the same part over and over and over again. So I'm going to pass this around. This is something that was CNC made, CNC cut with a drill. So basically this is a vase made out of aluminum, if we pass it around. And for that, basically I designed the top of it, and we were able to give it to a computer to basically cut it out. And so, but if I do multiple of those, I would have had a drawing of it. I would have bits and had my tolerances there, be able to say, these are the correct ones. Because even when you're doing a machine, a CNC, whatever, there's going to be inaccuracies in the machine. Nothing is perfect. And so sometimes they're going to be tweaking that machine, they're going to be running other stuff on that machine. They're going to use different cutting heads too. And all those wear away, they change with time, and you want to make sure your parts are going to be the same over that whole time period that you need that part. And that's why you're going to have the drawings. So those are two processes. Another one, a big one for plastic parts is injection molding. And basically what you do is you do a cavity and you fill with plastic. So this is an injection molded part right here. I'll get to this in a little bit later. But you basically pump a lot of plastic into this mold. And the way you make sure that all those parts, again, is the drawings. So drawings are very, very, very important in terms of product design and making sure that you have the right part. And in a lot of companies, there's a quality person or a quality section of that company that's basically what they do. They go to vendors, they talk with vendors, they compare it to drawings and make sure that the parts you're getting is the same as the parts you ordered. So as a consumer, you hopefully don't have to deal with that. But going back to drawings is, so you first have your part, you create a new part, you dimension everything in that part. And the dimensioning is very important in terms of how that's going to be made and what's going to be interfaced with everything. And so basically, Go here. So that's okay. So here's an example of a drawing I did for one of my projects. It works. So the biggest thing that you have to remember with drawings, I guess that, is the more complex they are, the more they may not be correct. There may be different things that are wrong, but what you need to remember when you're doing the drawings is what's the important parts of your drawing. That is, what are the main features of the parts, and what's important. So for this, in terms of documentation, you want a part number on it. Fairly simple, you can name it whatever you want. That's just so when you're communicating with other people, you say, I want NRC 007, and that's what you can say. The other thing is the material. So when you're doing a lot of parts, you want to make sure that you have the right material. Can be a wide range of materials. For here I use aluminum 6061. The other thing is if you look, oh, you guys should have told me that it's not up there anymore. Let's see if we can get back up there. Display. Anyone have any questions? No questions? Nothing? I know it's boring. There. Alright, so this is drawing here. Material, part number. And so if you look right here, this is one of my dimensions. And as you see, I have a plus 0.005 and a minus 0.000. Basically, that's what I'm calling out my tolerances. For all drawings, you're going to have a designated typical tolerance. You call it on your notes. But for example, if you have something that needs a different tolerance, you're going to call it out there. So it can be plus or minus 5 thousandths of an inch, just plus 5 thousandths minus 0, plus 5 thousandths minus 10 thousandths, something like that. And that's basically the range for that part. So for this dimension, it can go to 0.871 to 0.866, or vice versa, in terms of what I can measure. And that's basically just taking a set of calipers, or better measurement tools, and measuring, like this. And so you'll do this a couple times. Typically, when you have a lot of parts, you'll do statistical analysis on your part. Over like 1,000 of these, you'll take out 10, 20 of them, measure them, make sure they're all in spec. That's important because anyone have a guess what this is? It's okay if you don't. Okay. So I used to work at a faucet company, and this is basically call it that if you have a sink right here, so a sink right here, this piece goes right here. You have your faucet coming out right here, that goes onto this. And there's two O-rings that go around here. And basically O-rings are rubber gaskets to stop the water leaking. Well, you can't tell by looking at this, but one of these circles' diameter is smaller than the other. And what did that cause? Anyone can think?
It's gonna blow up.
Blow up? Leaks, yeah. So this caused leaks. And the only way we could tell our vendors that they had a problem was looking back at the drawing. So this isn't the drawing of it, but the drawing. Look at the dimensions and the tolerances of that circle and say, hey, this is the wrong diameter because it falls with it. It's not within our tolerances. So I don't know if you guys want to look at it. It's a fairly simple part. But this is injection molded. We talked with our suppliers, and they're like, yeah, we messed up. And so they sent us new batches of these that worked. We put new O-rings on them and sent out the faucets. And so that's one of the reasons why it's important to have these drawings. And going back, the key thing about these drawings is you're going to have all the dimensions that you need to call out. So if you look at this guy, I'm going to have dimension of the full thing. So basically what this is the top of a robot. There's a hole in it for mount and an emergency stop button. I can show it to you, but basically what I'm doing is I'm calling out where the screw holes are, where the cuts are, the overall dimensions of the part, where my brackets are screwing into. So in here you'll see this view right here. Basically, that's a cross-section view. So if you have the more complex part, you're going to have more images. So anyone know, going back, so this is what I have. If we look at the drawing of the part that I just drew up before, so this guy, if I wanted to dimension this, what are the important things that I would want to dimension? Yeah, Chris.
Length, width, and height.
Perfect. So, how do I do that in 2D? That's
Well,
so
2D
you know,
you would take.
so these are my 2D images over here. And what I do is I take one and drag it over. So which one do you think is the best image to start off with?
The left.
Left, this guy?
Yeah, that.
Yes?
Yep.
Alright. So, and then, so this is the proper way of dimensioning, but just to make it easier, in terms of doing it technically, but for practical purposes this will work as well. So what would I dimension on here?
Well, you would do the length as the bottom side.
This one?
Yeah.
Alright. 5 inches. Perfect. Alright. What else would I dimension?
Then the longer side, which would be the width.
Alright, well 1.32. And so, this is where we get into getting multiple views. So for any object, you're going to have a lot of views to it. So for this one, you have this view, which looks a lot different from this view. Anyone knows what the different views are called? Or how I switch from one view to another? In terms of drawing, yeah, Mark.
Well, one of them I know is isometric, or ISO.
So that's a view, yeah.
And then, wait, so how to switch between views, or?
So yeah, so say I have just a plain box like this.
Yeah.
How would, and I call this the top, so we have the front, we have the top.
Yeah.
If I look at the front, and what would go, which view would go over here?
It's like I don't know, I think side? Or,
Okay. Yeah, so, exactly, it'd be the side. And so what you have to think is, it's sort of, it's in a bowl, and you rotate it. So, if I just do something like this, on this side, it would be my X. And dot, dot, dot. If I were to rotate it this way, dot, dot, dot. Another way, so if we look in 3D space, we look at this. So this is your front view. If I rotate it, this is going to be top view. And if I rotate it this way, this is going to be side view. Does that make sense? And this is the standard of doing all your different drawings. So if we go back here, I can I can do my projected view right here. This guy. And it's going to show me my different views of my objects. So we have our top view, we have the side view, and we have the isometric view. So as you mentioned, the isometric view is basically it's a way of looking in 3D to better understand the part. You don't dimension isometric views. It's just a better way of being able to understand what the part does in terms of its function. So, Amar, what is the next view I need to dimension this part?
Well, we need to define the front, because, yeah, so.
So, where would I move my mouse?
Oh,
left,
yeah.
Right, down.
Wait, what do we, that one is, the one
This is left.
That's the left, right?
Yeah.
So, actually we should probably go right.
Move right.
Yeah, move. Oh,
Okay.
no, never mind, sorry. Go up.
Go up.
Yeah. there we
This
go.
view? Why this view?
Because we have to define the circle in the, right?
The circle and the...
On the top, because we haven't constrained anything there, so.
Right. So yeah, so typically in your parts you're going to constrain stuff to these dimensions. So that 11.32, I'm going to constrain when I did my part. Right here, it's not that important. And so you will notice when I did the circle, crosshairs popped up on it. And that's so we can dimension to the center of the circle. So what would I dimension on here?
So, we'll length and width first of the, or no, we already have the width, so we need the other side, the vertical, yeah,
This
yeah,
one?
yeah, that's fine, yeah.
Right. And so why don't we need this guy?
Because we already constrained it.
Exactly, because this one and this one are the same thing, and you only need to do the dimension once.
Yeah.
So right now SolidWorks is going to let me do this guy, but you shouldn't do it because it's already there, and it's just going to confuse stuff, especially if you only tolerance one and not the other.
Yeah.
What else do I need to do? Giselle?
Oh,
Do you do that?
Well, in terms of, so we're looking at just the top right now, or whatever you want to call this. What else needs to be dimensioned on here so you understand how to make it?
Or like the depth of the circle?
Depth of the circle. Right. Before we do the depth, what should we do?
The diameter?
Diameter, right. Oops, that's across here. And so typically what you'll do is you actually dimension the depth in the dimension of the diameter. So for here, we'll just say it's 0.2 inches, something like that. It's not really that important. It'll yell at you for doing that, but that's fine. The other way of dimensioning that is if I went all the way through, I'd label it through. So THRU. That's just telling the manufacturer just go all the way through. I want that same hole. Or if I was doing it threaded, I'd do my thread call out on that. So I wouldn't have a diameter call out, I have a thread call out. And that's like your 256 standard thread. You can see there's a standard means of calling on thread. I have my depth as well there. Okay, what else do I need to dimension on here? Alphin. If you were to make this, what else would you have to know? Well, so we're still looking at the top image, so it's still here. There's a dimension that's not been done yet, or two dimensions, or two constraints, whatever you want to say. You know? Alex?
Distance of the center of the circle and size.
Exactly. And so there's two ways of doing this. So right now, there's an implied placement of it. And anyone know what I mean by what that implied is? So it's implied that
Center.
it's the center, exactly. A better way of doing it is actually, where are we? A better way of doing that is actually to draw center lines. So, yeah. So actually it's not on the center, so it's a good thing. The better way of doing it is actually to draw center lines from top to bottom and across, which match up with the circle. So that's poorly done. But basically you want the center lines of the box to match up with the center lines of the circle. That way you can say it's in the middle. Another means is to dimension from one side to the center of the circle and from the top to the center of the circle as well. Part of that's preference, part of that is how many dimensions you already have there. And you want to try to keep it as clean as possible, but also say where it is. Okay. The other important part about drawings is just labeling stuff. So you can say that's an ISO view, you say comments, I want it to be finished, so how are you going to finish it? And so that's a lot of important to have a nice shiny surface. There's different ways of finishing stuff. So, and that's more into the manufacturing. But that's what you'll read comments at the bottom basically saying what that is. Is there anything else that we have to mention for this part? Giselle, are you shaking your head? You don't think so? Right. So we have everything in here that we need to dimension. So let's do. Are there any questions about this? Yeah.
Wait, so well, what would you do if you have to have more than, I think, wait, the most is 4 views, right, in a part document, or could you have more? Because I'm assuming when you have parts that are more complex.
Right. So if we go back to here, how many views do I have here?
Oh yeah, okay, yeah, more than 4.
So I'll go a little bit more into it. So first I have my ISO view over here,
Yeah.
and that's just so I have a better understanding what the parts list looks like at the end. That's not necessarily needed, it's nice to have. In my part as an engineer, because I'm looking at, oh, I know that part. Because it's kind of hard to see from the 2D what exactly that part's doing.
Yeah.
Especially if, so this is just cut from a 1/2 inch sheet of aluminum. If it's more complex part, it's harder to see what that is. And so then I have my bottom plane right here. And basically that's, because for this operation, I put it on a mill and just cut everything out. And then tapped and stuff. And so that's what this thing is right here. But some of the stuff is hard to see. So if I look at this feature right here, those features, that's hard to see. And so I have a detail view. Basically, detail is, I have a lot of stuff in one area. I want to take it to a different part of the drawing and say, this is what it is, so that you can actually see what it is. And this can actually be on a separate sheet. You don't have to have all the drawings on one sheet. These two views are cross sections. So basically that means is my part changing as we go into it. And if you can't see from an edge, so a good thing to probably cross section. I'm trying to think if I have anything good. So a good thing to cross section would be, so if my tape measure, if for some reason the orange part was one piece, I'll probably cross section that to be able to see the innards and stuff. So a lot of, if you want to do 3D print, do drawings for 3D printing. So that's another thing. If you're just 3D printing, you don't need a drawing for it, because the communication method is that 3D part file. But if, for example, I want to be able to have a lot of the parts tolerance, and the good thing about 3D printing is you can actually have parts in the inside. So, let's see if I brought it. So I actually do have a good part that I did have to do a good cross section for. I don't know what it is. I'll bring it in on Monday to show you. Basically, if you have a feature on the inside that you can't see from the outside, that's basically you take a cut of the part, a slice at that specific part, and you have a cross-section view of it. That's what that's for. Does that answer your question?
Yeah.
So, I mean, so you may have you can have your all 6 projections. That's just because the front may be different from the back. The two sides are different, and the top and bottom are different. Then you also have all the cuts in between, so your cross sections and your detail views too. So some drawings can go for multiple pages, just depending on how many features you have in. Any other questions? You guys think you can draw stuff? Caitlin, you look bored back there. Just thinking? I know it's pretty boring. I don't really like this when they try and teach us in school either. But it's a very important subject if you want to go into any type of product design or doing CAD or anything like that. So, what is the most important thing about drawing? Doing drawings. So you can call it drafting, you can call it drawings. What is the most important thing about them? Chris?
Being accurate.
What is that supposed to mean?
That the dimensions are really precise. And,
Well, of course they're precise, it's on the computer. So what do you mean by the dimensions are precise?
like they are the ones you specify.
So you mean the part? The dimensions of the part are what I specify in the drawing. Is that what you're trying to get at?
Yeah.
Caitlin, you want to help them out?
Or I was just gonna say being like thorough, so making sure you have like all the views that you know you need, and that like you're specifying everything, like where the circle's gonna be, like is it gonna be in the center, it's gonna be off-centered and everything like that.
Yeah, right, yeah. So maybe Chris, the word you're looking for was tolerancing?
Yeah.
Yeah, that's important, and so it really depends on what you're doing. So for this part, tolerancing may not be as important, but Josh, do you have something to add?
Yeah, and safety goggles too.
Safety goggles, always wear your safety goggles, yes.
Very important. And don't
Number
cut
one rule,
yourself.
and don't cut yourself, yeah. Thank you for reminding me.
Yeah.
So whenever you do CAD, you have to wear safety goggles too. Yeah, so remember, drawings are a communication method. And so in this day of age, basically when you talk with a vendor, you're going to be sending both the drawing and your 3D CAD. But part of the drawing came back from when we didn't have computers to do the 3D CAD. But it also allows us to be able to say, even though the part looks the same, it's not the same if you incorporate the tolerancing. Alright, any last questions? Okay, we'll get back to work. Get back to work.